வணக்கம். I am Dr. Srinivasan from the Department of Physics, Congo Engineering College. How are you, students? So today I would like to discuss about Raman Effect. Sir C.V. Raman, a great scientist from India, particularly from Tiruchirappalli. So he discovered this effect, so that this effect is named as Sir Raman Effect. Raman effect is nothing but scattering of light. So when a light beam falls on a substance, it will be scattered. So this is normal. When light photons falls on the atom inside the substance, they will be scattered. When you analyze the scattered light has three different components. First component, scattered photons with the same frequency as incident frequency. Second component, they have the frequency with lower frequency than the incident. Third component, scattered photon has higher frequency than the incident. So first case, scattered photons with the same as incident frequency. That scattering is called Rayleigh scattering. That is normal. Raman observed a different thing. That is, scattered photons have frequency different from the incident frequency. So this kind of scattering is called as Raman scattering. So Raman scattering, when light photons fall on the substance, the photons will be scattered. The scattered photons have different frequency than the incident frequency. Different frequency means frequency, incident frequency. There are two things, incident frequency and scattered frequency. The scattered frequency is different from the incident frequency. In what way? There are two ways. One is incident frequency, scattered frequency is greater than incident frequency, or scattered frequency is less than incident frequency. So Raman discovered this. So when light photons falls on a substance, they will be scattered. The scattered ray has photons with a lower frequency than the incident, higher frequency than the incident. So based on that, Raman explained two things. One is Stokes lines, another one is anti-Stokes lines. The scattered photon with lesser frequency than the incident frequency can produce Stokes lines. Next, scattered photons with a higher frequency than the incident frequency can generate anti-Stokes lines. So based on Raman effect, we have two different lines, Stokes lines and anti-Stokes lines. These are formed by the scattered photons. So when a light photon is absorbed by an atom or molecule in the ground state, that moves to the excited state, then it moves to the next lower energy level, so that it releases a scattered photon. That has a frequency lesser than the incident frequency. So Raman shift delta nu equal to nu I minus nu s. Nu I is incident frequency, nu s is scattered frequency. So Raman shift is nothing but difference between incident frequency and scattered frequency. So when Raman shift is positive, Stokes lines are formed. When Raman shift is negative, that means scattered frequency of scattered photon is more, then Raman's shift will be negative. So when Raman shift is negative, anti-Stokes lines are formed. So normally Raman spectrum is a plot of when you go through the Raman spectrum, normally Stokes lines, they are more intense, anti-Stokes lines are less intense. Stokes lines are more intense, anti-Stokes lines are less intense. So this is due to the absorption of energy from the photons, incident photons, by the molecules in the ground state forms a Stokes line. Absorption of incident energy from the incident photon by the molecules in little bit higher energy state, not ground state, excited state. So in excited state, normally number of atoms will be less. In ground state, number of atoms will be more always in normal state, in normal condition. So that intensity of anti-Stokes lines are always lesser than the intensity of Stokes lines. So possibility of production of Stokes lines will be more because of more number of molecules present in the ground state. They will absorb the photons, incident photons. So to conclude, Sir C.V. Raman discovered Raman effect. So according to Raman effect, when light photon incident on a substance, it will be scattered. The scattered photons have different frequency than the incident frequency. Stokes lines are formed with scattered photons of lower frequency than the incident frequency. Anti-Stokes lines are formed with the photons of higher frequency than the incident frequency. So this effect is called Raman effect. So we have a very good analytical tool for finding the chemical structure of the material, that is Raman spectrometer. Thank you for watching.